In your homework packet, you should have a diagram that looks like this that you can use to take notes. So we are going to talk about phase diagrams. A phase diagram summarizes the conditions at which a substance exists as a solid, liquid, or gas. So if you look at this phase diagram down here, we have temperature at the bottom and we have pressure along here on the side. There are some solid lines and they all meet right here at what is called the triple point. So the triple point is where all three phases meet. So this is where we will have an equilibrium situation between solid, liquid, and gas. Each of those solid lines is an equilibrium line, and it divides the phases. Along that line is where we have equilibrium between the two phases. So the solid liquid line right here, this is where melting or freezing would take place depending on the direction you're going. So this is where solid and liquid would exist at equilibrium. And then the liquid vapor line over here, this is where boiling would take place all along that line. So all along this whole line is where it could boil, depending on what the pressure was. So this is where liquid and vapor will be at equilibrium. And there is one more line. It's a solid vapor line. So that along this line, this is where solid and vapor will exist together. Notice that the pressure and the temperature, they work together to have all these different areas. Also, the order that you see on these phase diagrams, you will always see solid be in this first space, liquid be in kind of the Y area, and then you're going to have your gas that's over here on the right. So no matter what your phase diagram looks like, so we've been working with water, but some look a little bit different like that. But they're always going to go in the same order: solid, liquid, gas. So you can always find and use those equilibrium lines to help you figure out where the phases of matter are. So in order to determine the normal boiling point or melting point of something, you're going to use atmospheric pressure. So remember, one atmospheric unit is equal to 101.3 kilopascals, which is equal to 760 torr, which is equal to 760 millimeters of mercury. So all of these are atmospheric pressures. So you have to figure out, well, what pressure is it going to be measured in? And then when you find out whatever the unit is, then you can find standard pressure. So this is in kilopascals, so I'm going to find the 101.3. I'll just draw that pressure line across, and where it crosses the solid liquid line, that is my normal melting point. And if I keep drawing, that I'm going to find my boiling point. And again, that's called the normal boiling point. So again, when it boils and melts normally, it's going to be right along that standard pressure line. I could, instead of finding melting point, I could find freezing point. If I was coming from the other direction, I was freezing the water. I also could condense the water by going from a vapor to a liquid right there at that standard pressure. One more point before we move to the next slide, and that would be the critical point. The critical point is right here. I'm going to put CP for critical point. And it is made up of the critical pressure and the critical temperature. The critical point, it means that past this, it will always be a gas. So no amount of pressure can force this gas to become a liquid. It will always be a gas if it's past the critical pressure or past the critical temperature. So your phase changes are right here. So you need to be familiar with these phase changes. So anytime I cross my solid liquid line, that solid liquid equilibrium line, I am either going to be melting it or freezing it. It just depends on what direction I'm coming from. If I'm going from a solid to a liquid, that's called melting. A liquid to a solid is called freezing. Along my liquid gas line right here at equilibrium, I'm either going to boil it or vaporize it, or I'm going to be condensing it. And then along my solid gas line, the equilibrium line, I have sublimation or deposition. So sublimation is when you go directly from a solid to a gas. Dry ice does that. Deposition means you go directly from a gas to a solid. A good example of this is if you go out in the morning and you look at your car windshield and there's this thick ice on it. What's happened is overnight the water vapor in the air, it has deposited on your windshield. And so that's going from directly from a gas or a vapor to a solid. So you should be familiar with these phase changes. So if I gave you a little test like this, and I said if you went directly from C to B, what is that phase change? So going directly from a C to B, I'm going from a gas to a liquid, so I would be condensing. What do we call it when we go from B to A? Going from B to A, that would be freezing. And describe the phases of matter as you go from A to C. And going from A to C, I would first melt it, and then I would boil it to get to C. So if you increase pressure on your substance, you will force that substance to go to the most dense state. Now, water is very unique in that its most dense state is liquid. Most everything else, the most dense state is solid. So again, if I'm, say, right here on my chart, and I increase the pressure, I can get to turn to a liquid, but then I will turn it into a solid. For water, it's different. Let's say I'm right here. I can go directly from a gas to a solid, but with increased pressure, I will turn that into a liquid. So given a blank diagram, you should be able to tell me the normal melting point, the normal boiling point. You should tell me where it's a solid, a liquid, or a gas, and you should be able to tell me the phase changes. So go ahead and just kind of review on this blank diagram, and then I'll come back and just go over it one more time with you. Okay, we're back. So first of all, I have temperature here and I have pressure here. I can identify that this is my solid area, this is my liquid, this is my gas. This is probably water because this is a negative slope. See how it goes off to the side here? Most other substances, they have a positive slope for that solid liquid line. Again, because their most dense phase is a solid. So water is very unique. Its most dense phase is a liquid. All right, I know my triple point is right here. My critical point is going to be way off here, which is made up of the critical temperature and the critical pressure. So there's not really enough here to show where that critical temperature it is, but maybe it's right there. And it does have a critical pressure. So probably not enough room on this graph to show the critical pressure. So I'm drawing a little squiggly line, meaning it's not counted in even units. I could figure out my normal boiling point and my normal melting point. So this right here is my normal boiling point, and this right here is my normal melting point, right there. And that's because I have standard pressure right here, where that is. And I should know some phase changes. So I know going this way, that's sublimation. Going this way is deposition. This way is boiling. This way is condensation. This way is melting. This way is freezing.